Hello, everyone. Welcome to today's webinar. For those of you who don't know me, I'm Erin. I'm the Operations Director here at Forestry, and I have the pleasure of getting to host most of our webinars. With me today is my colleague, Matthew Dickey. He's going to be doing all the heavy lifting of the webinar. So today, really, it's all about forestry as we continue our industry series. So it started couple weeks back, we kicked it off by taking a look at how RoadEng can apply for mining. If that happens to be applicable to you, there's a QR code here on the screen. You can scan it, check out that webinar. Pretty awesome. We got into benching pits and some more mining specific functions and features. But today's about forestry. If you are interested in some of the other topics, we are continuing the series. It is a 4-part one. And we're going to be looking at county engineering as well as renewables in the coming month. But today, as I mentioned, we're really focused on forestry. And forestry has a lot of different tools and workflows that you can actually do that are quite specific inside of RoadEng. We have cable harvesting tools, of course, those are quite applicable, steep terrain, which is really not all of our forestry clients, as well as a new tool that's coming out in version 12 called digital planting. That tool is great if you're working in plantation design. It helps you to be able to understand, basically how to lay out your plantation. So those tools really not going to be the focus of today's webinar. We're honing in on that core project type that happens in pretty much every forestry application. That is an access road as well as landings that go alongside it. So that's going to be today's focus. If you are, again, interested, checking out cable harvesting, digital planting, we hosted a great webinar back in October. Happy to put the link for that in the chat for today's webinar, as well as into the video YouTube link, which reminds me, our housekeeping for today. Everyone in the live webinar, you're muted. But please feel free to engage with us at any time by opening up that Q&A section of your GoToWebinar panel, and you can type your questions. And if you're watching this on YouTube in the future, be sure to hit the subscribe button as well. You can drop any questions into the comment section below and we'll tackle them. Okay, today's topic, a little bit different in terms of how we're talking about RoadEng for forestry. Today, we're really talking about it in terms of the process that you go through. As you start in the office, you've got a project you need to do. This is going to be your preliminary design phase. So in that office section, we're going to look at building that terrain model, including some hydrology tools for how you can model your streams and ponds, as well as a new feature that's coming in version 12 called the polygonization tool. So we're going to be able to use that to identify different areas of our terrain that are perhaps too steep. We're also going to take a look at landing design, and then, of course, that prelim road design, get that figured out, where should the road be, and get that exported to, say, something like Avenza. Then we're going to go on an imaginary field trip out into the field, collect some data, and then we're going to bring that back into the office again for that detailed design phase. So being able to include a LiDAR and your P-line data that you collected together, being able to include some information from the ground types that you you collected, sorry, words. And then finally, we're going to be showcasing a couple new tools from version 12. And I should mention, this entire industry series really is a way for us to sprinkle in and get folks excited about some of the stuff coming in 12. So today's webinar, we're going to feature a couple new version 12 tools. That includes the polygonization tool, and then the two tools we're going to have here in that detailed road design part. So we're going to include hydrology in location. This is awesome if you want to understand the impact that your road is having on natural drainage patterns, as well as if you're trying to figure out where to put culverts. Hydrology in location makes that a whole lot easier. And then on the output side, as we finish off the webinar, we're going to take a look at a new function and feature called 3D viewpoints, as well as how you can then use those 3D viewpoints in your output sheets. So that's really, it for our plan on a page. As I said, it's a bit more workflow focused in terms of what you're going to do time-wise. So before you're at the field, in the field, after the field. For those of you who are new to RoadEng, although I see so many familiar names, lovely to have all of our regulars back in the webinar today. RoadEng is modular. So when Matt gets into the software, he is going to play in two different modules, essentially two mini programs. The first of which is our terrain module. Inside of terrain, this is where we're going to handle building your topo surface. This is where you would design a landing, although there are ways to do it in location. We might touch on that. This is where you would do digital planting, cable harvesting, and then our super fun tool, Path Explorer AI, that lives inside a terrain. Although noted here, it is a Softtree optimal function, so special licensing needed to get access to it. And then we'll head over to the location module, and that's really special module for our corridor design. Okay, enough from me. Let's get into preliminary design. I'm going to attempt to pass the screen to Matt, and we are going to really answer a couple of key questions. Where should my access road go? Where should the landing go? Where's the water that we might want to avoid? And is there any terrain or features or steep terrain that we might want to avoid as well? Okay, I am going to flip my camera off. Nice to see everyone. And we will get into it here. Okay, Matt, believe you have the screen.
There we go. Yeah, it was taking a moment to switch screens on me there. Cool. So I guess as per usual, we'll start right from scratch and run through our project. So I'm going to start in terrain. And we're going to bring in our survey data. So in this case, I'm going to bring it in. It is DEM data. So typically we'd use DEM and LiDAR data interchangeably. We'll just bring that guy in and we'll hit OK. And we're going to take that information and we're going to turn it into a surface. So we'll come up here, we'll click this. Now we could create contours at the same time. I'm going to skip it. But we'll generate a surface from those points that we've brought in here. And there we are. So we can see our little study area on where we're going to deal with things. Now for this, this would kind of be the bare minimum that we could run with. So we want to have some kind of a surface to design with and we'd be set. But of course, usually we don't just have the bare minimum. There's other pre-existing data sets that we'd like to visualize and use as we kind of interpolate what's going on. So I'm going to bring in some of that information. It's going to also kind of selfishly help me paint a bit of a picture here for what we have going on. So I'm going to bring this in. I've got several shape files that we're going to just dump in. So to start, I've got some existing roads. We're just going to make those a little heavier, easier to see. So we've got our existing roads and we've got our proposed block boundary. So where we'd like to get. I'll make that a little heavier as well. Now we could go through and try to figure out how to get from here to there, but there's other things that, well, would be nice to know. So with this, I happen to already have some pre-existing data sets for water areas. So I've got lakes. We're going to bring those in. And again, just to kind of help show what's going on, we're going to make those visible. And we're also going to bring in a layer for our rivers. Now here I happen to have a river layer, and it's got the main water courses on this surface, but it doesn't have a lot of the smaller streams and ephemeral streams and what have you. So to help augment what I'm considering beyond just the stuff that I have layers for, pre-existing layers for, I'm going to use our hydrology tools. So we'll come up here, we'll click this guy, and I'm going to use the streams and ponds tool, and we'll hit OK, and we're going to see that this gives us a bunch of lines for those smaller order streams, and it also gives us a bunch of polygons for areas where we expect there to be issues with ponding. So yeah, obviously water's pretty important. If we try to figure out from how to get from here to there, well, recognizing that there's crossings is an important part of that. And, well, aside from just having vectors, we may want to have an image in the background here. So we could go on here, we could click import, and I could bring in the imagery from Google, Bing, our own data source if we wanted here from a WebMap tile surf source. But I already have one downloaded. So save having to wait for that to download. I'm just going to click connect. We're going to add that in here. All right, so I've got kind of enough to start really unpacking this problem. And well, for our road, we want to start at the existing road, and for our block, we want to go somewhere into the block that's going to be of use for us. So I'm going to just kind of pan around here. And for this, my example project, it's not a cable analysis problem, so I'm not going to worry about grapple yarders or skylines and running deflection analysis for that. I'm going to just choose my landing location based off of kind of operability and forwarding distance. So with that, I probably have a maximum preferred forwarding distance. But I'm going to push my road near the end of my block, and I'm coming out to the boundary just because this is kind of on the verge for whether we can tackle it with ground-based equipment, and I don't want to have my guys running a side hill. So we're going to add a point here, and we're going to call this point end. And I'll make it a draped point. We'll come in here, and sure, we'll set that right in there. And choosing a location gives us a little bit of a flat area here. So if it was a more extreme terrain, I might actually do the grading for my landing and expect some earthworks. But here, I think we can use that and just deck the wood where we'd like. And of course, not required, but just to make it a little easier to see, I'm going to make that a 3D symbol. Yeah, so that's one of the points we'd like to go to. Now, we could tell the software to go from our start point to our end point. So I'm going to add in a start point. And we'll do this kind of much the same way. Just going to give it a name. And we'll make it visible here too. So that's our start point. If we tell it to go from here to there, it will. So using Path Explorer, and it'll find the most efficient route to get there. But I don't want it to just find the most efficient route. I'd also like to guide it towards well, kind of the midpoint of my block, in this case, the long skinny block. I want to make sure I'm not too far from either side and have landings other than just that endpoint. So same concept. I'm going to come in here and I'm going to just add in one point. We're going to call it a midpoint. And once again, just so folks can see it as I'm clicking around, it's kind of easy to see on my screen, but might not be given the, yeah, just sharing things. So, and introducing a V12 functionality, instead of just going point A to point B, we're going to use the connect in sequence. So point A to point B to point C. Now, another thing that we may want to do here, and aside from just having our water courses delineated, lakes delineated, etc., is we could tell it that there's other areas that we don't want to go. And if we don't do that, the software is pretty smart. It uses a cross section. So it's going to inadvertently kind of avoid steeper areas. But even though it's going to avoid steeper areas, if we want to say, well, all these big bluffy areas, they're solid rock, I don't even want to consider them in terms of spots to put my road, well, we could use that polygonize function that Aaron mentioned. So for that, I'll come up here, I'll hit polygonize, and I'm going to tell this thing to identify anywhere along my whole surface in this case that I have slopes greater than 85 meters, or sorry, 85 meters, 85%. So I'm going to just throw that number in here, and I'm going to make it kind of black polygon, nice, easy to see and obvious, and we'll run that. So of course we could run that with different gradations representing different things, but here I'm just kind of going absolute. If it's one of those bluffs, we don't want to excavate there or try to get there for the sake of reducing earthworks. Yeah, not worth the hassle. So I'm going to set this up. I'm going to click optimization. We go into Path Explorer, and I'm going to, well, tell it what features to use. So those of you that have used Path Explorer in version 11, we're changing it a bit in 12, where we're defining the features by, well, connection points, I guess I should say, by features, rather than just a single feature. So I'm going to grab these 3 features. Since I'm connecting them in sequence, I'll shift that up, shift that down. And then I'm going to tell it that we've got our max grade of 12%. I'm going to keep my minimum horizontal curvature set at 35. Generally, I like my excavation and fill costs, but I'm going to add in construction zones to account for those really steep rocky areas to avoid the lakes. I don't want to cross that river again, so I'm going to add those in as no-go polylines. So we'll come in here. So populating, let's do the feature slope ranges to start. Then we'll do our lakes, and then we'll do our river. So no-go polylines. And even though there's some polygons in there, no-go polyline won't let us cross into it, just as though it were a polygon. And then I'll come down here, and those ephemeral streams, those minor crossings, I'm going to add those in, and I'm going to say that they cost more. So, and I'll say each one of those costs about $4,000. We'll hit OK. We'll hit OK. And we'll let this run. So it should be fairly quick for what it spits out.
And this is a good point to remind everyone who maybe was late joining, missed the intro, sprinkled into our entire webinar series right now are going to be tastes of our new version. So what Matt's got up here, and he's already done a couple features, the polygonization tool, and then some improvements to Path Explorer, which I should say are still, there's massive improvements still coming in the next month. But these are new. If you want to try them, we'll come back at the end of the webinar and talk a little bit about beta testing. Sorry, Matt.
Oh, perfect. All right. And yeah, so we've got our Path Explorer solution. And yeah, if I want to see which one of these compares to the other, I can come in here and I can see, well, I've got, well, a cost of 552,000 for that. It's the cheapest of the bunch. It also happens to be a nice location down the midst of our block. So that's what I'd run with. And so with that, we'd hit File, Save As, and I'd save this as my topo train. And of course, Aaron acknowledged it. There's that field verification aspect of things. But before I did the field verification aspect of things, I would take this over to location and further flush out what this geometry actually looks like. So we're going to just minimize this. We're going to go over to location. We're going to click New File. And we'll reference our topo. We'll use that selected feature as our initial alignment. And well, we'll set this up to kind of continue down the process. So we took the time to add in that background image previously. Let's throw that in here as well. And well, we have that Path Explorer solution. Now it's considering our curve constraints, but is a polyline. So I'm going to take this and I'm going to run that polyline to alignment tool on it. All right. And I would make sure that my cross-section geometry is appropriate. So in this case, well, I want to run with a 6-meter wide road. My default is fine for what we have here. And then to have a better idea of what I'm dealing with in terms of cuts and fills and kind of interacting with that surrounding terrain. First pass, I'm going to run my vertical optimization without adding in a bunch of details like ground type information, or go through and with a fine-tooth comb and use different templates if there's things that I'd like to do differently at certain locations. So setting this guy up here, and let's run with that. We'll put in our specs. And actually, since it's kind of a first pass, we'll refine it later. I'm going to just sample less than every cross-section point here. Just keep it running along. We'll set our crests and sags, add in any control points that we'd like to take into account. So vertical control points, and we'd hit process, and we'll let this thing run. And yeah, not instantaneous, but again, kind of like Path Explorer, it's solving a really big problem here, and it's doing it yeah, it's considering a lot. So, but it will spit out an optimized vertical here momentarily. All right, so we've got our vertical alignment, we've got our quantities. Again, haven't accounted for a ton of detail in terms of what's there in terms of our ground types, but we can see what we're dealing with, and we'd be moving about 17,000 cubes. We can have a peek at that in the 3D view, and then, well, and kind of teeing it up to go to the field and verify what's there, we could put together our documentation. And if, I guess before we put together the documentation, if there's anything that we'd like to add in, maybe in terms of culverts, we could absolutely add those in too. So go over to this, we'll multiplot, bring in a book layout. So we can see that, and then I could hit File, Save As, export that out as an Avenza file. So my plan view could be georeferenced, and I could go make sure everything is where I'd like it to be, collect subsurface information or traverse it if we want to have a P-line referenced with our LiDAR-based design as well. And away we go. So with that, I'll pause there.
Excellent. And I'm going to steal the screen back here. Okay, so let's pretend now we're heading out to the field. We've got that preliminary design in Avenza, got ready to take some notes. And really, the purpose of this adjusted workflow is to help you make better use of that field time. So instead of going to the field and asking the general question about where should my road go, and spending time trying to answer it there. You now have a plan in hand, and you're really changing that question to why should my road not go here? So out in the field in our pretend exercise for the moment, we are going to collect some P-line data, as well as we're going to collect some ground information about yeah, what's happening if there's rock, what the different materials are that we have to work with. And we can bring those back in now to our design once we get back to the office and be able to make some intelligent adjustments to it. So that's it for our field trip. That was super fun. Back to you, Matt.
So there are a few different ways, and I'm just going to add a little bit of context here. When we're out in the field, we could collect our data several different ways, and we could do it with our GPS, and just run with that, flag it in, take notes and add those notes back into our design with the assign by range functionality. So this ground type from X to Y. Now you could take that GPS information and bring it back to the office, and you could save it as a TR1 file. So bring it into Train, save it as a TR1 file, and you could create a traverse file out of it. And that would give us the functionality to have offsets based off of what's ribboned in the field. But with that, not everyone is super comfortable with relying on GPS coverage under canopy. So it's still fairly common to see people collect hand traverse notes for their forestry roads. And if you're in that group, well, you'd collect them, again, several different ways, but it could be with a laser using the app. It could be on something like a Mesa tablet, entering that data right in the survey map module in the field, or it could be collecting paper notes and then data entry once you get back in the office. Big thing here is I've got, and without doing it with the GPS, I've got my horizontal azimuths from station to station. I've got a distance. And the most common, or the most, the thing that's really hard to capture from just looking at the LiDAR data, and it's much nicer to do it with boots on the ground, is adding in the information regarding your ground types. So here I've added in my various ground types from station range in my P-line file, so I can see that. And then if there's any other notes, we can take it as a comment, and we can use that to help us refine the design. So in this case, we're gonna, well, assume we actually went to the field here in this little session and did our hand traverse. Note, I didn't bother with any side shots here since we're using the LiDAR data to define our surface. Just captured centerline information, ground type information, and anything else that I'd like to know. So that is the survey map module, and we can save that as a TR1 file. And then you can take that and you can bring it into location. So here, if I've gone to the field, collected that information, and want to bring that TR1 file back into my design, I can come up here, I can click options, I can see this little P-line spot here, and I can say, well, I want to add that in here. And there is some functionality with that P-line that if we wanted to have the full functionality associated with it, we'd save our file and reopen it, but I think we can capture what we'd like here without it. So right off the bat, I can now see, well, at this particular location, where my L line, so my design center line, is relative to the ribbons in the woods. And then the other nice thing here is, well, my ground type information was in that file, so I can see my subsurface information is populated along my geometry. So I don't have to go in here and click assign by range. For my subhorizons, it's pulling that from the TR1 file. And then, of course, if there's anything else that we'd like to add in, and I took a note, we could make it so our P-line notes are visible in here. Let's, oh, and that is of course one that we'd have to close and open the file to see our P-line comments. But if we did that, there would be a note that says key in our rock here. So at this stage, while I've got my ground type information included, I'd go through and probably start refining things if I needed to have a different cross section for a particular area. So let's take this particular spot. So we'll go from 1190 to 1230, and I want to have that fill keyed in, and we'll assign a template for that. So we'll come up here. If we don't already have one in our template library, we could build one out from the eLibrary, but I have one that's called rock fill. So we're going to use that. I'm going to assign that on the left side from 1190 to, let's go 1210. Oops, and I didn't click the right thing. 1190 to 1210. There we go. Now, the other thing that we could do, and we could do this for different station ranges, but if we want to add in our stripping depth, and here I'm going to just run with a global number. I'm going to say strip 8 inches off of everything. So 20 centimeter depth based off my slope stakes. So top of cut, toe of fill. We'll add that in, and now we'd be considering all that extra information as we, well, maybe re-optimize our design, which we typically want to. I might not do it just to save a couple steps, and then we could go through and continue to add those extra details. And of course, I dropped the pipe here before. Again, coming back to some of the stuff that's being introduced in version 12. Well, we could do those kind of stream calculations right in location now. And if we do that, well, I'm going to say that my road is merged into the topo surface. So by doing that, if we calculate the streams from here, it's going to account for, well, any water that hits our ditch and is redirected by the road. Well, in this case, if it hits the ditch and is redirected for the road, we're concentrating more water at that crossing location. And we're robbing some from here. So we'll be able to see the impact of that using the streams tool. And then where we're concentrating it at a culvert location. So I've got this guy here. I've got that guy tagged as being included in the hydrology calcs. We could do our drainage area to that culvert inlet for us. So we'll do that. We'll come up here. We'll click both of these. I'll use the same minimum drainage area as what we did in terrain for that kind of apples to apples comparison. Worth noting here that I'm only using one pipe. So the other side that we'll be able to get from this is see anywhere that water would be overtopping our road, or see where we're concentrating a lot of water. So we could run this once and then go back in and quickly add pipes where we recognize that there's obvious issues. So we'll hit OK. We'll hit OK. And again, another one that's a relatively large problem, especially if you have a large surface. So we'll take a moment while it does its thing.
I will take the opportunity to remind our audience, ask questions. We're happy to tackle them at the end of the webinar. You type in the GoToWebinar Q&A section of your panel. Yeah, those will be tackled at the end.
All right. And well, let's kind of back up here. So in my plan view, again, keep in mind, it's kind of intentionally sparse on pipes so we can show the impact of things. But all of this water in that hatched area is coming to that pipe. We could quickly throw together a quick data table for our culvert locations. And we'll show our L station, and let's do, oh, I want to see my culvert diameter, culvert length, but again, new to 12. We'll include the drainage area, and we could include the flow length, flow slope, storage, etc. if we wanted to. So you've got the inputs in order to plug that into something like the rationale method to get an appropriate culvert size. So there we are. Square drainage area in square meters, flow length, so the maximum flow length to the most hydraulically remote point, and then the slope, the average slope of that flow path. So we can see that. That's the pipe that we've added. And then, and again, just to kind of differentiate what's what, well, these streamlines that are more of a teal than the blue that we have before, we can see that, well, if we didn't have a culvert here, we'd be robbing the flow from that ephemeral stream, redirecting it down the ditch, Waterwood Pond, and overtop our road there. So two things, we might be okay redirecting that flow, or we could come in here, we could add a pipe at that point, and we should add another pipe at this point since it's a low point. So it makes it very easy to run through and well, see where you should put your pipes. Of course, it's kind of repetitive. We'd go through, add them anywhere that it's necessary, and re-optimize our design, and then we'd come back in here and finalize our documentation, add extra information that we'd like to add, annotate, maybe turn off the other Path Explorer solutions in our background terrain, or if we're done, maybe we just delete them all together. And voila. So with that, I think I've got a rare instance where I've got a little bit of extra time.
And that's when your co-presenter reminds you to chat about 3D viewpoints.
Oh, yes, of course.
We're never on time now. Come on.
yeah. Let's add that back in. So yeah, the other thing that meant to include in this one is 3D viewpoints. And I'll let this update, but we'll back up to what we're working with here. So if I were to, well, maybe as I'm designing, zoom around and decide, well, that's a good, important spot. It's got a difficult section of our road. We've got a culvert in there. Maybe I'm going to add a little bit of a sump on that culvert inlet. If we decided that was important and we wanted to, well, save this view, we could click that and we'll say big draw. So we'll give it a name. And then if we wanted to come over to, well, another location, and yeah, let's do right there. So I'm going to add in another one. We'll call it end of road. And then the nice thing, well, one, it's nice to just be able to switch back and forth here in the 3D view if we'd like. But it's really nice to be able to say, well, I want to add those in to my document. Let's just take this as our kind of starting point. I'll remove that. And we're going to add in this guy. So I'm using the end of road. Great. And we'll add in another one. We'll make that. So we can have our multi-plot that references the geometry that's live in our design and really help make it easier to well, communicate what the expectations are, communicate maybe a 3D overview, and add extra context for those difficult sections as needed. So yeah, 3D viewpoints, super cool. And yeah, can't believe I forgot to mention them. Yeah.
That's all right. Covered a lot of ground in today's webinar. Obviously, we focused on a workflow. Started in the office, went for an imaginary field trip, came back in and adjusted the design. With that, we also featured a whole bunch of different version 12 functions and features. And you might be wondering, why are we doing this? Why are we showing you version 12 when it's not really available? Which is kind of true, kind of not true. So if you are a client on support, we are happy to let you join our beta program. We have beta testing. It's active now. It's a couple phases of it. Currently, all the function and features that Matt talked about today are available in beta testing. Yeah, so if you want to join the program, just shoot us an email. You can run it alongside your current version. And we'll get you set up and really guess maybe take a moment to reiterate kind of how our development program works here at Softtree, which is really, we are a very user-centric company. We listen to client requests for features. We will listen and watch how they're using the software. And of course, the feedback that comes in from our clients during beta programs is, absolutely taken into consideration and very essential to our process. So if you want to be part of that, shoot us an email. We'll get you hooked up. And with that, Matt, probably makes sense to make you the presenter again, just to tackle some questions. But we do have a few to start here in the chat. And the first one really is about landings. They want to know if it's possible to grade a landing.
All right, so landings. There's a kind of like a lot of other things. There's a few different ways we can tackle them. And just to reiterate here, I just kind of went the easy way, basically planning to deck wood on the native ground. But if we wanted to have that actually graded out, we could, and we could do that. Well, I think the two broad buckets would be, well, maybe we want to just have it as a road widening. So not worry about any grading and location. Just come in here and we could say, well, maybe we do it as a wide template. Now I'm kind of a fan of not using a new template for that. So if it was just a case of having a standard width from say this point to the end, we could come in here, assign by range. We could click overrides, and I'm going to go down to my width here. And I would say, well, I want to add in an override that starts at station 2400. And we'll have that taper out to be a new width. Let's shoot to get this out to 10 meters by 2410. And then we'll carry that new width right to the end of our road. So we can use template overrides to, override a template parameter from a certain station to a certain station. So there we are, we have that. Now the other way, and I'll run through this quick, and alternatively, instead of using an override, if we wanted something that was a little bit more irregular shaped, but still part of our road, we could, either use a terrain feature, or we could use a location alignment or feature, and we could draw in where we want the edge to be. So here, kind of the same idea. If I wanted to make that something a little more irregular shaped, we could just draw in an alignment. I'll go a little further than it's needed for the sake of making it a little prettier than it otherwise would have been. I'll add in some curves. So we could use that alignment that's called H-Align1, and we could tell the software that I want to have my road edge to go out to wherever that feature is. And if we did that, we'd do it in our templates, and we'd use a reference feature in our templates. So there we are. And we'll hit OK. And there we are. We can see it's going out following that feature that we've drawn in. And of course, it's a cross-section based model. If we are missing any sections, we can add those in as report points. So that's kind of tackling the main strategies for while doing that larger landing area earthworks as part of the road. Now the other strategy we could go with here would be to do it in location, or sorry, in terrain instead. And if we were to do it in terrain, just kind of stepping back, we've got our topo file here. I would do my landing grading in another instance of terrain. So we'd have one terrain file as our topo, another terrain file as our design surface. So right off the bat, new instance of terrain, we're going to click plan options, click the little plus here, click add, and we are going to add in that background topo. We'll also add in our image just for that extra context of being able to see what's what. We'll click zoom to extents and we'll zoom into where it is that we're dealing with. So if I want to do a landing, say right there, I'm going to either hit Control F or go up to the ribbon here. I'm going to call this landing. And we could just draw in whatever shape it is that we'd like. Now, that line that we've drawn, I just ran with it at an elevation of 100. We probably want it to be close to our topo surface, so I can use the hover tip to see that my topo at this location is about 471.2. So with that selected, I could shift it up to be, well, maybe I want it to be 472. Great. And we could hit terrain modeling, generate, and we could generate a surface for just that line, but this is going to be lacking. Now, I'm just going to do that for now to add context. We'll zoom in here so I can see my current surface in my 3D. And again, this isn't necessary, but we are going to just add it as a means to add a little context. So we can see that we've got that pad elevation, we've got our topo surface, but there's nothing connecting anything here. So if I wanted to grade off of this feature, I could use the grading tool. And I could tell it, well, I want to grade to the outside, which is the left. I want to grade to my topo surface. I could set my fill slopes to be whatever I'd like. I want to create grade lines every so often, so I'll go every 5 meters here. And we'll tell it that we want to calculate our volumes as well. So there we are. We could see that we've got a little bit of cut and 13,000 cubes of fill. So that's one way to do it. And there's lots of cases where you'll want to have your pad at a specific elevation. But I think most of the time, at least unless there's something else going on, we generally want these pads or landings to be balanced, minimizing our earthworks. So if that were the case, instead of just using the grading tool, I'd go to the optimization ribbon. I'd click auto balance, and I would tell the software, well, a lot of the same parameters. The only difference is that we want to specify whether we have a surplus deficit or if we want that number to be 0 and balance out. So we'll leave that as is. We'll hit OK. We'll hit OK. We'll let that iterate as it kind of searches through until it has a location where our cuts and our fills are equal. And there we can see we're about split for how much is cut, how much is fill. And then we could design our road up to that landing site and not have to worry about adding the widening in as part of our road. So.
Awesome. And with that, very long answer to one question. We are actually out of time. So for the people who have asked some questions that are still in the chat, we're going to follow up with you independently and in regular Softree webinar fashion. We are over time, so we just want to thank everyone for being here today. Thanks for joining us. Hope you guys enjoyed today's content. Yeah, have a great rest of your day. See you at some upcoming webinars. Thanks, everybody.
Thanks, everyone.